Okay, good afternoon, everyone. Uh, as mentioned, we're looking at the importance and advantages of a thorough hazardous materials design. Just to give you a quick outline of what we're going to discuss today. We're going to start with a little background about the components and functions of a hazardous materials designs and some of the common hazardous materials that you would see in buildings. Then we'll look at items to address, factors to consider when we are doing an abatement design, and then the benefits and consequences of not of having a good sound hazardous materials design or not having one available. So how that can affect your project with those conditions. And then finally, we'll look at some factors that will influence the thoroughness of that hazardous materials design. All right, so to start out with the hazardous materials design, what we're talking about generally referring to the plan for abatement or remediation of hazardous materials containing items in a building or a structure. You could also do some exterior type site remediation for environmental concerns, soil excavation, utility removals during abatement and all that stuff. But we're really not going to get into that portion of it. We're mainly going to focus on, a building during a renovation or a demolition process and how, the abatement design affects those types of projects. Now, as you might imagine, this is, hazardous materials abatement design would be valuable for any project that would involve the disturbance or potential disturbance of suspect or known hazardous materials containing items. Some of the things you might see, we'll get into a little bit later. Asbestos is a big one, lead-based paint, PCB containing materials, but there's also some others, and we'll discuss those a few slides into this later. What you see when you get a hazardous materials design, it's typical of any other type of discipline with building designs and such. You're going to have drawings, you're going to have specifications, you're going to have cost estimates prepared for the owner to get an idea, how much the project may cost before they actually send it out to bid. You also will have, with the hazardous materials, you're going to have investigation reports, the survey reports that show you, that things have been sampled, they have been evaluated prior to doing the design, prior to actually disturbing materials in the building, so you know what you have going into a project. And also there might be some remediation plans or variances through regulatory agencies. Variances are more typical, with your asbestos containing materials, site-specific variances you apply through the DOL to really get relief from certain parts of the regulations there. And then the remediation plans, you might see certain projects with PCB remediation might have a plan that goes through the EPA for approval that would be implemented during an abatement or remediation. So the primary functions of hazardous materials design, several functions, but we're going to discuss, mainly what the main criteria for them. So obviously you want to identify those hazardous materials. You want to know what they are and what you're dealing with before you get too far into a project. You want to locate them. Where are they at? Are they in the areas of renovations? Or demo building? Where are they at for the demo? So you can adequately assess those and remove them before other work. Quantify the materials. So it's important for contractors when they're looking at bidding a project or looking at the extent of removals of a project, that they have an idea how much they're going to be removing and where they're at and how they're going to remove them. Obviously, regulatory criteria, hazardous materials, environmental, heavy on regulations. There's certain protocols that have to be followed to remove, to perform the abatement. So you want to establish those regulatory criteria. A lot of the abatement contractors, they're going to be familiar with those. But when you get into, some things that aren't as common, maybe asbestos containing materials, they're really thorough with those regulations, but they may not be as familiar with PCB remediation. So you want to establish those regulatory criteria in that design. And then there's other items that may not necessarily have specific regulations that dictate how to abate or remediate. For instance, a mercury containing floor system, which we'll discuss a little later. There is no set established regulatory criteria on how to do that work. So what you're looking at, okay, is there's past projects, past experience that showed that certain methods were useful in removing that and keeping the mercury concerns at bay. So industry standard protocol will come into play for something like that. And finally, phasing and timing. It's important to know how you're going to schedule your abatement. Obviously, you got to get the abatement done before other work. But if it's a multi-phase project, can you do abatement in different phases? Do you do it all up front? So establishing that in your abatement design, letting the contractors know that, okay, you're going to have, certain materials that are come out during the first phase, certain materials come out the second phase. That allows them to bid it and allows the owner to get a project that, is on time, within budget, and all that good stuff. So what are we leading to when we do our hazardous materials design? The results that we're looking for to make things better for the owner, make the project go smoother. All this comes into play. Some different things we're looking at. Obviously, we want to limit worker exposure. This also limits, the building occupants. We want to make sure that they're safe, they're not being exposed to the hazardous materials, so they're implementing the right protocol and containments, so that nobody's being overexposed to any of these hazardous materials. Safeguard the environment. Obviously, we want to protect the surrounding areas. We don't want to release these contaminants into the other areas of the building or the environment, so that you have a bigger mess to deal with. So contain that work area. Make sure that design calls for protocols to protect those surrounding areas. Promote efficiency. A good thorough hazardous materials design can help a project transition from abatement to the other work during different phases. It can promote that efficiency if it's well described and it's defined, so that there's no guesswork there and how things are going to move along during the project. So you get everything set up, nice clear direction in your design, and you can have some efficient results. Control costs. That's a big one. Everyone wants to control costs, minimize what it's going to take to do an abatement and remediation. So if it's on paper, if it's defined well, and everything's identified appropriately, then that's an obvious factor that can be affected with your project. Mitigating future hazards. That's big, and that's important as you go through looking at design. So if you take a renovation project, if you're just going to do a partial removal on materials, does that, it might get the project done, but does it benefit the owner in the end, as far as, are they going to avoid the hazards, in the future when they're doing routine maintenance and type work in the building? Or does it make sense to try to remove all the material during that initial hazardous materials abatement, so they don't have to deal with it at all? And reduce unknowns. There's always going to be unknowns in the world. In any goal of a design is to reduce and mitigate those unknowns, and try to establish them up front so you can appropriately address them if you have to during the construction phase. You may not eliminate all the unknowns, but at least you'll have a plan to address them if they are there and they are encountered during the construction project. So with that'll bring us to question 1.
Continue.
Okay, so question 1 was, which of the following is not a primary function of a hazardous materials abatement design? The answer there is B, detailing new materials in the areas of abatement. So that comes with other trades, other designers will identify those. The abatement design will cover the other 3 items on that list. All right, so taking a little step back, as far as, we're headed in the direction of doing an abatement design, what materials are we concerned with? Very commonly, just because of heavy on the regulations, there's set protocol and, procedures, and they've been established for a while. First up, there's the asbestos. So asbestos containing material, we're looking at any material that contains greater than 1% of asbestos. And, with that, you could imagine, okay, what do we do for something that might have asbestos less than 1%? And what third bullet down, you see the materials of trace asbestos. So we classify those materials as trace asbestos. They don't require specific abatement per New York State or EPA regulations, but there are still some protocol from OSHA as far as exposure potential with materials of trace asbestos. So there are there's an OSHA standard that describes what to do with asbestos materials, and that does include trace asbestos. So sometimes in a design, we'll have awareness notes for trace asbestos materials, but other times, it may just be better off just to allow the client, to set that up so the abatement contractor takes care of those materials so that no one else has to deal with them later. Other contractors may not be well suited to deal with those materials, so it might be more efficient just to schedule as abatement, even though it's not necessarily per the regulations, needed per the regulations. So also when we're dealing with asbestos materials, we have this thing, friable versus non-friable. Friable being materials that you can pretty much crush, pulverize by your hand, and you would release asbestos fibers. The non-friable materials, you're not going to be able to do that, like your floor tiles, your caulk materials, your tar materials. You're not going to be able to pulverize those by hand. So they're a lot more stable, a little easier to deal with. So on the design side, that comes into play as far as, removals, how you set up your containment attached versus remote decontamination units, how you have to remove those materials and prep the work area. And then on the disposal side, so, design will account for what you would need to do for those different materials. Another item I have up there listed is vermiculite, and, there's, a lot of questions there with vermiculite. The main thing to know, is with the loose fill vermiculite, so things that you're going to see in block fill or you might see in attic areas, that is a material that we can't test in New York State currently. There's no methods that are approved to allow you to analyze that, so it is an automatic assume there's asbestos in that type of vermiculite material. So whenever you do have that, it's something that should be covered in design. You got to remove it, you got to address it if it's in the block walls or in an attic area or wherever else it might be, and it's going to be disturbed during the project. That doesn't, you may have heard on the surfacing type materials, your spray applied fireproofing type materials. It doesn't really apply specifically to that. We do have analytical methods that you can do to see if that would be classified as asbestos containing materials, which is important because, as you can imagine, you get into some high-rise buildings with a lot of spray applied fireproofing. It's friable material. If you can do that additional analysis and prove that it's not asbestos containing materials, that saves a lot on your abatement. It saves a lot on the cost for renovation and demolition work. So that's kind of the difference there. There are some methods for surfacing materials to analyze, but there aren't any current methods for your loose fill vermiculite. Next up, lead contained materials, and the big one being lead-based paint. That's the most common. There's some other things. Sometimes you test for caulk materials, other building materials that might have lead in them. But the big one's lead paint, and a couple different definitions of lead paint from OSHA. OSHA defines lead contained paint as any detectable concentration. So there's no set standards. If it's got lead on it, similar with asbestos. If it's got asbestos, OSHA covers it. If it's got lead in it, OSHA covers it. HUD and the EPA, they actually define lead-based paint as 1 microgram per centimeter squared, or 0.5% by weight. So that kind of dictates when their regulations and requirements kick in. So when you're dealing with child-occupied facilities, if you have lead-based paint, you follow their standards and regulations. So really, the lead paint criteria from HUD, EPA, OSHA, that's really going to depend on, when that applies. Really depends on your current planned usage, more so on the HUD, EPA. So if it's a child-occupied facility, or it's going to be converted, or it could be used for child residents or occupants, then those lead-based paint requirements would apply. PCB, polychlorinated biphenyls, that's another common hazardous materials you could have building, especially with caulk materials. If you sample those, you determine that you have greater than or equal to 50 part per million. It is considered an unauthorized use and would require removal and remediation. So whenever you have PCB containing caulk in your survey and your design, that would require removal. There may be some PCBs and other things, electrical equipment, transformers, capacitors, light ballast. We'll see a slide a little later on some of those items, but yeah, there's definitely some regulations out there that pertain to PCB, mainly on the federal level. New York State here and many other states have adopted the federal regulations for their PCB remediation efforts. So something to pay attention to when you have a project that might have those materials. Mercury containing materials, universal waste items, and we'll have, like I said, we'll have a slide a little later on those. But you know, some of the things you might find in building materials, you might sample mastics or caulks, and they might have mercury in them. Another big item is that the New York State Education Department issued a memo in 2019 referring to mercury-containing flooring. So this is typically a soft poured in-place floor. They use them in gymnasiums commonly, you know, prior to 1990s, 1960s, 70s installations. Also, you might see them in multi-purpose rooms or cafeteria areas, things like that. You know, these were common in those buildings, large floor spaces. You know, and lo and behold, they were made with a mercury catalyst product. So a lot of times they're not much of a concern in place intact. Some of them might have high enough concentrations where they are off gassing during, you know, as is, but most of them, if they're left in place, they're not a huge concern. But obviously when you do go to remove those, if you're not doing it in a contained, controlled environment, you could release mercury vapor, and that can be very, very hazardous and toxic to the occupants. So definitely want to control that when you remove it. New York State doesn't have any regulations, requirements for it, so they refer to Minnesota Department of Health guidance, and the Minnesota Department of Health guidance does have a document titled Mercury Flooring in Testing and Mitigation, so guidance for environmental professionals. So that's very useful to refer to that when you are designing mercury floor removal. But the actual procedures and methods are left up to the designer. So you're going to want to reach into those industry standard protocols, what's worked in the past, what methods have been successful in the past, and go off from those and continue to try to improve upon those. We also have mold. Mold's a big one, becoming a bigger one. New York State enacted some legislation in the past few years regarding mold. So there's mold remediation requirements. There is some confusion with that as far as, is it required? When's it required? The dollars required? Well, the main thing with it is if you're dealing with a mold project. So there is the New York State Article 32 of the New York State Labor Law. It does have a definition for a mold project. So it's important to know that it's it doesn't apply if you're doing removal as part of construction, maintenance, repair, or demolition. It's basically if you're going in and you're looking to do just mold remediation, that's the sole intent of that, then this law kicks into gear. But if you are doing it part as a renovation project and such, it doesn't really apply. With that said, an owner may still want to go ahead and go through the whole steps, all the whole process, just to make sure everything is covered appropriately. So they may still at their option follow the requirements to have it assessed as a licensed individual, have it remediated by licensed individuals, and have a mold remediation plan in place to do that work. So we got asbestos, lead, PCB, mercury, mold. Then you have a lot of other things that you might encounter in a building. Universal waste items. So the federal definition for universal waste would your fluorescent lamps, batteries, things like that. But also miscellaneous hazardous materials containing items. So some examples of what we're talking about here. Fluorescent lamps with mercury, light ballast, PCBs. Thermostats and switches may have mercury. Some other smoke detectors that you see a picture there. You have radiation type smoke detectors, so you want to make sure that those are being disposed of properly when they're removed. Not really, the radioactive material is encased and closed, so as long as that unit's not damaged, there's no exposure really, but you do have to dispose of it appropriately because it has that radioactive material. batteries, exit signs. Exit signs are more, they have battery systems with exit signs, but you might see some older exit signs that, are self-illuminating. So those will have like what's called tritium, radioactive material. So again, you want to dispose of those properly. Refrigerants, CFC, HCFCs, you want to make sure those are appropriately addressed. Petroleum containing equipment. You might have stored chemicals in a building, drums or cleaning chemicals that need to be disposed of. So, those have to go through the whole channels of disposal. E-waste, you want to make sure those are recycled properly. And then, general waste materials in the building. There's New York State has regulations as far as how you manage waste. And if you're not, a transfer station or landfill facility, you can't have waste just sitting around on your site. You got to take care of it and get it to one of those permitted facilities. So, if you have a renovation project and you got a bunch of waste sitting outside, it's a good idea to get that taken care of and out of there too, so you're in compliance with New York State requirements. All right, so now we have question 2.
And a quick question on the percent of asbestos. Is that measured by weight, volume, area, or something else?
That is percent by weight.
Okay, go ahead, Cheyenne.
All right, so question number 2, removal of mold contaminated materials at construction sites always requires a mold remediation plan per Article 32 of New York State labor law, and that is false. So if you have a construction renovation site, you don't necessarily need a mold remediation plan, but can do so at the option of the owner. We'll also do question number 3 at this time.
Okay, go ahead, Cheyenne.
All right, question number 3, which of the following is not commonly associated with hazardous materials? The answer there is B, the incandescent lamps. So the fluorescent lamps do have mercury. Incandescent lamps, the typical lamps you put in your light socket, those do not have any contaminants of concern. All right, so enough questions for now. We'll get back into some has design stuff. So on the design preparation side, there's a typical cycle. Obviously you want to start with, a review of the project scope of work. And ideally you have a defined project scope of work or somewhat defined project scope of work before you get into doing a hazardous materials survey. Otherwise, unless you're surveying the whole building, you might have some things that get missed, that don't get picked up on the survey. You could just imagine if you add things after the survey, that survey isn't covering it. So, the more defined your scope of work is before you do the survey, the better results you're going to have with your survey and with your design subsequently. So timing of that survey is critical. Obviously you'll have design deadlines, you'll have project deadlines and all that, and you want to meet those, but you don't want to get that survey done too quickly because you may end up having to go back and redo some things. So just some things to consider on that front. Once you do a hazardous material survey, when you get into the design portion of it, you're looking at doing the hazardous material design. Obviously you're developing your abatement plans and specifications, but you also want to, it's good to have the designers do their own site review. And it's good that if those designers aren't, the representatives that did the initial survey. So you want to get a second set of eyes on that. You want to make sure that, if there were changes to the defined scope of work that, after the survey is done that things have been picked up, or if there's homogeneous materials, okay, yeah, it may have not been sampled, but it's homogeneous to the ones that have been sampled, and we don't have to do additional analysis. Or it may identify that you do need more sample analysis. So it is very critical to do a site review to make sure you captured everything and make sure you understand the scope of work relative to the hazardous materials that need to be removed. And then, obviously, as I mentioned, the modifications through the design phase, it happens, things happen, especially when you're estimating costs for a project, you may see that you have to cut some things, which is a little easier to deal with. You can always cut the abatement out as well. But you might realize that you've got a certain amount of money for a project and you come in under that budget, and maybe we can get a few more things done. Well, when you make those changes, you got to keep in mind that you got to assess those hazardous materials. Was that area that you're changing, was that fully assessed for everything, or do you need to go back? And then, if you do go back and find something, you got to account for those abatement costs, as well as, the additional work that you put into the budget. So there's a lot of things you want to look at to address when you are preparing an abatement design. Some of the things we went over a little bit earlier, but you're looking at compliance with regulations. That's definitely, number one priority is making sure that you are complying with all the existing federal and state and local requirements out there. The owner or the sponsor of the project may have their own requirements. So like I said, you may not necessarily have to do lead-based paint abatement in a certain type of building, but maybe the owner or the project sponsor wants it done to make sure that they're following similar protocol that you would follow on a lead-based paint abatement project. Locations and extent abatement, you obviously want to identify that, and also the quantities of removal. You want to make sure that those are described appropriately, especially if you're not removing the entirety of the material. So if you're just doing a portion of it, give them a basis for that bid. Other removals during the work or removals of work during abatement. This might be, if you got some flooring to abate, you may have cabinetry, you may have other things that are covering that flooring. So you want to describe that has to be removed as well by the abatement contractor. There may be other things like that it may be preferential just to take it out during abatement rather than have it left over for demo. So if you're going to a room and most of the things you want to remove are being done during abatement, maybe say, okay, let's just remove all the other things as well. And then the GC can come in, they can just start their new installations. They don't have to worry about removing more materials. Existing conditions, plan conditions, you want to make sure you're aware of what's out there currently. Maybe you have some disturbed materials already that you have to do an assessment and clean up on during your project. You may have on the plan conditions side, you might be converting an old commercial building to a residential building. So you need to know that, if we're dealing with lead-based paint, you should have all those criteria in there. Accessibility, that's a big one. In your design, you want to be careful. You want to be careful to mention where you might have elevated areas where the contractor would have to bring in specialized equipment to access those. Or confined space type entry. You could just imagine a demo project. You want to, just straight up demolition, just trying to get access to certain things is a chore or challenge in its own right. But then you add in the factor that you're doing abatement and you got a contained, controlled work area with polyethylene sheeting all over everything. What do you have to poly? What do you have to clean? So you're bringing in lifts. Those lifts have to be cleaned and all that good stuff, or protected. So, those things you want to make sure the abatement contractors are aware of. Phasing and scheduling, how's the project going to be phased and scheduled, and how does that affect your abatement? Are we looking at doing all abatement up front during the initial phase, or are we going to do abatement in that phased approach? If a certain project got 3 phases and you're doing 3 phases of abatement, so that tells the abatement contractor, how many mobilizations they're going to have to make and what they're going to be able to do under each mobilization. Material disposal, there's standard stuff for your friable asbestos waste. There's standard protocol for your PCB waste as hazardous materials, mercury as hazardous materials, lead-based paint, testing and characterizing it. So, we want to make everyone aware of what needs to be done with that process, and there's time frames that you can have certain waste on site, so make sure people are aware of that, so you're getting the waste off site in the appropriate time frame. And then there's items that if you have mixed asbestos and PCB, certain facilities aren't going to accept that way, so you got to make sure that you're going to have to look into where those have to go for disposal. And then finally, monitoring and sampling. Not so much what the contractor doesn't have to be aware of. They're not providing the monitoring and sampling, but they have to be aware of that being done, and what there might be time frames for sampling analysis. So, if the contractor is going to want to get in, get their work done, and get out, but they got to be aware that it'll take a day or two to get certain samples back from the labs. So specify that up front, and everyone's aware of it, and it makes things go a lot smoother. Factors to consider when we're doing abatement design: building vintages. You want to, obviously you could have different materials in different building vintages. They may have all the same finishes due to a recent renovation, but what's behind those finishes could be different. So you want to assess and address those different building vintages separately. Prior renovations, again, did they put new materials over old materials? So what you see is not always, what you see is not always what you get. You might have, nice gypsum board up front, not a big deal. And then behind it, you got some old plaster that is asbestos that needs to be removed, or something to that effect. So, or floor tiles, newer floor tiles on top of older floor tiles. Well, the problem's still there. You still got to address it and abate it. Then you look at prior abatement or remediation, and in the last 20 or 30 years, we've had some pretty good regulations out there, pretty good protocol about how you clear a work area and how you do your abatement. So usually if you have an abatement project that was done in the last 20 or 30 years, it probably took care of the problem and got rid of it. But if you're looking at some abatement projects that go further back than that, you might still have residual asbestos kicking around. Maybe it just wasn't cleaned and cleared, to the standards that they usually are today. So you may still see that residual, and it's kind of it could be a surprise, but if it's there, it's something you need to address and take care of and get it out of there before you do the other work. Building usage, intended building usage, we touched on that earlier. What are you intended to use it for? There's certain protocols for residential use, things like that you want to follow on lead-based paint. So it is important to know what you're going to do at the end of the day. Concealed materials. You may not fully assess concealed materials during a survey. You may have, wet wall systems where you have insulation inside those. You're not going to tear the wall apart to get to those, just to assess it. But at least in the design, you can say, okay, we're pretty confident, or it's going to be assumed that we're going to have asbestos-containing insulation in those walls. Let's just remove those walls as an abatement project. And if there is insulation, you already contained, you already got containment up, you can remove those materials under abatement. Everyone's happy. If there aren't any materials, well, you could just tear down your containment and everyone else can go about their work, and again, everyone's happy. So account for your concealed materials, even if you don't know specifically whether they're there or not. That goes along with your inaccessible. And then a contamination assessment. So if you do run into conditions that are, materials that are disturbed, you might have to do that contamination assessment up front. You may have to do, some abatement before, the actual project, your actual intended project gets underway, if it is an immediate health or safety risk there to occupants. So you might have to preemptively do some work. So, should be prepared for something like that. So some other factors to consider on the extent of removals. Some things you might look at is, do you remove all the materials, or you're just removing a portion of them? This might be, especially on a renovation project, you may not be touching all the ACM in the building, but, does it make sense to just go ahead and remove all from certain areas so you don't have to the owner doesn't have to deal with it later? Or, are there budget constraints? You only really want to remove the things that are affected. So that's a discussion that needs to be had there during that design phase. On similar lines, do you remove a material or do you remove the whole component? So this might be common with, say you have sink that has an asbestos coating on it. Well, it doesn't make sense to really spend time and labor and effort to remove the coating off the sink if the whole sink's coming out. You just have the abatement contractor remove that whole component. You might also see this commonly with your window replacement projects. If you have asbestos or PCB containing caulk materials or lead-based paint on the frames or the sills, it may be just easier to have the abatement contractor go ahead and remove the whole unit intact. That saves from potential impacts, cross-contamination to the environment. It takes things out intact, so you're not scraping paint, you're not scraping ACM or PCB, and it takes a lot less time. So you might have a little bit more on your disposal. Disposal costs might be a little bit more, but the labor cost usually outweighs that, and component removal can be effective in that instance. You might have a situation where work activities are not affected by hazardous materials, but it's in close proximity to it. So, take your friable pipe thermal system insulation. You might be doing some work on some boiler units and such that are in close proximity to that, but you're not touching that pipe insulation. Does it make sense to still remove that material so that you don't have any inadvertent disturbance, you don't have any potential for the workers to accidentally disturb that material with the work? So those are things to consider. And if you don't remove them, does it make sense to at least have the abatement contractor, if they're on site, at least put some poly over them, so in case someone does bump into them, it's not creating a mess or a bigger mess than you would have if it just fell onto the floor and it doesn't expose people. So whether you're removing or you're protecting it, those are things you should consider when you're working in close proximity to materials that might remain. Abatement remediation to account for work by all trades and disciplines. This is important on your projects with multi-prime contractors. So a lot of times your abatement contractor is going to be under the GC's work. They're going to be a sub to the GC, but they still need to account for. They still need to take care of hazardous materials that are under the mechanical contractor, or electrical contractor, or plumbing scope of work. So you want to make sure your design accounts for that. And this is critical, to coordinate the design drawings. So the mechanicals and electricals and plumbings, they should all have notes referring to abatement if they do need to be abated before their work, so that the contractor doesn't jump right into their work without having that abatement done. And then items without hazardous materials that need to be removed as part of the abatement remediation scope. We talked a little earlier, so like a flooring situation, you may remove cabinets and all that. The abatement contractor would have to remove those materials. Or you might have that asbestos pipe insulation in a wall behind a gypsum board wall that doesn't have any hazardous materials. Well, the abatement contractor still needs to remove those wall systems in case you have debris or damaged material behind it. You don't want the demo contractor, the GC, removing that and discovering there's a mess that isn't contained. So those sort of things you got to account for. You got to make sure that they know, okay, the abatement contractor's got to remove these even though they're not a hazard. All right, so on the conditions to remain, so once you get done with the hazardous materials abatement, you want to make sure that the hazardous materials are in a suitable condition for future work. So sometimes, something that's an obvious condition, but sometimes you want to specify, how that's done. So if you're removing pipe insulation on a portion of a pipe and you're leaving the rest of it there, you want to make sure that they seal those ends so that anybody else doing in that area, you got nice sealed ends that they don't have to touch. You want to make sure remaining surface compatible with new materials. This is common with floor tile, floor mastic. So if you use a mastic remover, is the new adhesives going to be compatible with that mastic remover, or is it not going to work? So you want to make sure that new materials can be installed without any issues, regardless of the methods, in consideration of the methods you use for the abatement. Encapsulated and closed materials, if you have those, are they going to be done and left in an appropriate condition? Are they going to be appropriately labeled, identified, documented so that people know future work or future building usage, that those are there and they're not to be disturbed. Are conditions sufficient for patching? You know, you got to make sure that you're leaving things in a condition that people can come back and do other work. So there's nothing against someone coming and putting a material over top of asbestos material, over top of lead-based paint, you know, if it's not disturbing it, but you want to make sure that is suitable. So you don't want to, you know, you don't have loose flaking paint that someone has to repaint. You know, and make sure that paint, that loose stuff is scraped out of there, even though, you know, you may not be removing all the paint. You want to make sure the loose stuff is out of there. Make sure the material replacements are specified. So this is a design coordination item. If we're removing something on the abatement, obviously something might have to go back into it. And you want to make sure the architectural plans and other plans account for that. You don't want to take a bunch of pipe insulation off and leave, you know, the project doesn't account for putting new pipe insulation on. So, you know, the different design disciplines definitely want to coordinate that, and you know, that's all part of that thorough hazardous materials design and make sure everything's coordinated. Cleanup and damages. Once you're done with abatement, you want to make sure that, you know, finishes aren't disturbed if they're not going to be disturbed during future work. Sometimes it doesn't matter. Sometimes, you know, they're going to remove those materials anyways, so the condition of them doesn't matter so much. But if they're things that are going to remain, you want to make sure that you don't have adhesive residual or, you know, tape, you know, left behind. You want to make sure that's all taken care of and gotten out of there. So put some conditions in the design to account for that. And also secure and safe conditions subsequent to removal. So, you know, this comes into play a lot of times with your, you know, like a window removal or door removal. You want to make sure that, you know, the building is secure and safe and protected from the elements or you know, someone breaking into it. So, you know, and make sure whether it's the abatement contractor or it's the GC or someone else that's sealing those up. So make sure that's accounted for in the design. Some factors to consider for scheduling and phasing, you know, accessibility and timing. When you do the abatement, do you do it all up front? Do you do some piecemeal? But you want to make sure, you still got to make sure that any abatement in an area is done before other work's done. So you can coordinate contractors to do work in other areas of the building, but you really got to get hazardous materials out of an area before someone else comes in and tears into it. Continued site operations. This is a big one, especially when you're dealing with things like a hospital where you really can't shut things down. You know, that's a good example for, you know, you got to continue your hospital, your site operations. How do you do that while you're trying to do abatement? How do you do that while you're trying to do any type of work? So, you know, are there things in place that you can do to restrict the area, restrict the work area? You know, do we have to specify certain phasing and scheduling on that? Available shutdowns. If you're doing, this is big when you're doing like insulation removals. If you have like a steam system, you know, can you shut down steam during, you know, summer months to get abatement done? You know, do you have backup plans? You know, so all that needs to be accounted for up front. Working in different areas, you know, there's nothing saying you can't do abatement in one area and have other work in another area, but you know, just making sure that abatement's done first if you need it. So, you know, sometimes you might do a multi-floor building, start abatement in the top or start in the bottom floor and work your way up or down, and then other work can come follow it. Multi-phase projects, talked about that already there. And then putbacks, you know, some things you might see like a roofing project. So, you know, if you remove the roof, you want to try to put those materials back as soon as possible so you don't have issues with rain and all that good stuff. So, you know, a lot of times you might see the abatement contractor, you know, the roofing contractor also be the, you know, have their abatement license so they can do the removals. You can remove for half a day and then you can get a clearance and then you can reinstall for another half a day. That works out pretty well. You might see that also on exterior facades with windows. You know, rather than trying to board a window system up after you abate it, you might just abate it, move your work area, have someone else be able to come in and do the window replacement right after them, so you don't have that opening. Some other factors to consider: site operations, interior, exterior work. You want to make sure you have appropriate containment. What do you have available on site for electricity, water, heat? Does the contractor have to provide that? You know, so timing of your work. If a contractor does have to provide water and heat, you know, it's better to try to do that type of project in the summer than it is the winter for obvious reasons. So, you know, that might factor into your schedule, your work. Access to or through non-work areas. You might still have to, you know, you might be doing abatement in a certain area, remediation in certain areas, still have to gain access through areas that they're not doing work in. So do you time, you know, you time the work so they come in early, shift work, things like that, so they're not impeding upon operations, you know, so those sort of things you want to describe in that design. Are there appropriate waste and equipment storage areas? You know, certain facilities, just for aesthetics, you don't want, you know, all the stuff laying around if you do still have to have operations going on in the building. So are there other areas they can access outside, out behind the building, or things like that? So, you know, the logistics of that, you know, might want to point that out right up front. Impacts on site occupants and operations, and then site-specific variances. We talked a little bit about those earlier. Direction and scope. You also want to consider these items. You want to make sure your direction is clear as it can be. The more clear, the better. That'll avoid some conflicts there in the construction phase. So a lot of times, the more detail, the better on these hazardous materials designs. Coordination details with other design disciplines. So make sure there's cross references on your drawings, and make sure that all contractors are aware of what needs to be abated before they can do their work. You want to make sure you're appropriately describing those existing conditions. Scope additions, deletions, this I talked about earlier. This is very important. This is where communication comes into play a lot during the design phase. Like I said, if you do some additions or scope deletions or modifications after a survey is done, you might not pick these things up. So, you know, that designer needs to be aware of these. They need to be communicating with the architect and all that, just to make sure that they are seeing these changes and making sure they're accounting for them in the hazardous materials design. Because, you know, sometimes that goes uncommunicated, and you get in the construction phase, and you know that's a big oops there. You got a whole area that you didn't design for on the hazmat abatement. All right, so that'll bring us to question number 4.
Please continue, Cheyenne.
All right, question number 4, true or false? Building materials without hazardous materials can always be removed prior to abatement remediation work to reduce costs. That would be B, false. Like I said, there's certain situations where, you know, a wall system, ceiling system, you got to remove it under abatement because the material above it might be in a condition that needs to be contained. All right, so just looking at some of the benefits and consequences. So this kind of relates to, you know, benefits and consequences of having either, you know, having a hazardous materials design and then having a thorough one. So obviously, if you don't have a hazardous materials design, you leave it up to the contractor to do what they need to do. Yeah, you know, for small projects that could get, you know, might not be a problem, but when you get into larger, more complex projects with multiple contractors, multiple things going on, usually better to have a plan. And it's usually better if that plan is nice and thorough and well thought out. So there's some obvious things that could be impacted: costs. You know, a good plan will have less change orders. You know, a lesser plan, where you're going to get more change orders. You might exceed your budget or contingencies, and that means you have to cut some things from your project. Nobody likes having to do that. Schedule wise, you know, obviously delays. or can you appropriately phase a project versus inefficient scheduling that can lead to more delays. Exposure, obviously we want to reduce and prevent exposure as much as possible. You have a good plan in place, that helps with that. You don't have such a good plan in place, you could increase the risk not only for the workers but also the occupants who may unknowingly be exposed to something. And then finished conditions, if you got a good plan, the owner will be happy with the finished conditions usually. And if you don't have a great plan, then you might have conditions that the owner isn't so happy with, and then it becomes a fight to try to correct and fix those deficiencies. Some other benefits and consequences: design coordination. If you got a good coordinated design, more cohesive design plans, everything works together. Contractors don't have as much guesswork in that, whereas if you don't have as great of a plan, then things can get a little messy, a little muddy in the design, in the construction phase. Construction management, a good thorough design can help assist the construction manager in phasing, scheduling, detailing, and getting the work done with a lot less challenges and obstacles. Whereas if it's not as thorough, they may have some RFIs, more RFIs to deal with, more potential change orders to deal with, makes that a little bit more of a nightmare to work with. And some other work, how does hazardous materials abatement design affect other work? Obviously if you don't get everything done in the first shot, that's going to limit what people can come in and do after. They might run into roadblocks and they might have to stop their work to do some more abatement. You don't want to have that. You want to get all that abatement done up front so others can go in and do their work without hindrance. And then unknowns. I mean, we're not going to eliminate all unknowns, and that's true for anything. You're never going to eliminate all your unknowns, but if you can identify things that are an unknown, you can appropriately address it. So if you account for them in your design and you call them out and you say, okay, this is how we're going to deal with this. If we do encounter it, you're going to have a more favorable response to those unknown conditions. All right, so last thing I just wanted to discuss today is, the factors that may influence the thoroughness of the hazardous materials design. There's a lot of things that go into it, especially when you're working with other design disciplines. You want to have a good, strong team that works well together and communicates. Some of the items that can affect your hazardous materials design is that, first thing first, the meat and potatoes of the design, the hazardous materials survey. So if that was done, done well, and you were able to sample all the materials, you got a pretty good picture of the building, that design goes pretty seamlessly. If things weren't totally complete and you're having to redo some things, reassess some things, or it wasn't picked up during that, then your design could suffer there. So that's why I say it's really important to do a design site review. A lot of people expect that it's in the survey, right? So whatever's in the survey, do your design on that. Well, yes and no. You don't always know the conditions that were presented to the surveyors up front. So things may have been missed, things may have not been communicated to them. It's really important for that designer to understand what wasn't picked up and to account for that. Site accessibility, that can affect the design. So if we can't access a lot of things during a survey or design phase, that's going to increase your unknowns. Yes, you can account for the unknowns, but that could also affect your costs, your bids. The more unknowns, the more they're going to put into the bid. So if you can reduce them to as much as possible with site accessibility conditions and other conditions, you can reduce those bids that come in. Clear and defined project scope of work, and this goes all around, not just on the abatement, but in other disciplines. But if everyone's project scope of work is clear and defined, you're going to have a good project. If things aren't well defined, there's some things here, that's just going to trickle down to the asbestos abatement or the hazardous materials abatement. So you may not account for everything up front if things aren't well defined, and then that becomes a change order in your construction phase. And, obviously don't want those. So that communication, design team coordination, I mentioned that earlier, very, very important to have good communication, good coordination. Owner involvement, owner expectations. you know, this is critical for anything. You want to make sure your owner knows what they're getting. They're involved with the design process. They're making the decisions that need to be made on their level, and you want to make sure that their expectations aren't unreasonable. You know, you may have to temper some of those expectations. This is what, you know, you're expecting this, but, you know, with this budget, this is what we can get you. You know, obviously you want to make sure everything is done in an abatement design appropriately, and we're eliminating hazards. We're not doing anything. We're doing everything by regulations. So those expectations they have to be in line with that. Budget and financial project restraints, you know, that can really affect any design on any side. You know, if there just isn't enough funds to do things, you know, things get cut, you know, and you really can't mess around with, you know, abatement remediation, especially with regulations. So there's things that you just have to do. And if you don't have the budget for it, you know, that could really put a hamper on how well things turn out. So, you know, just keep that in mind as you're going through the planning phase. And then time restraints, you know, there's always, you know, timing is of the essence, but if you don't have enough time in your design phase, you're trying to rush to construction, things are going to get missed. Things are going to, you know, things get added, modified, deleted, and, you know, and not communicated in time to you know, the HAZ design, you know, things could get messed up in a hurry. So sometimes you just got to take a step back and make sure that things are done and designed appropriately, regardless of what those time restraints are. All right, so this will our last question, number 5.
Discontinue Cheyenne.
All right, question 5, true or false, a hazardous materials design will eliminate all unknowns for hazardous materials in a building, and that answer is B, false. You know, it's just, it's not really practical to eliminate all unknowns, but at least try to control them as much as you can. All right, so that does it for our presentation today. If there are any questions, I'll field those now.